Alright, so I think I'm recording. Let's take a look at some selected problems from our homework over Skill 7B. Alright, now we'll start out with problem number 1. For all of these, the directions are saying to simplify. Now, when we want to simplify a complex number, we want to write it in what they call standard form of a plus bi. We refer to a as the real part and the b as the imaginary part. Alright, so we have a 1 and a negative 2. We have a 4i and a negative 5i. So it's very much like when we first learned how to add with variables, we look at like terms and unlike terms. The real parts, we add those together. 1 minus 2 is a negative 1. And 4i take away 5i is minus 1i. Now, of course, some people may just write it as negative 1 minus I, and that's fine. And so that's our final answer. If someone asks you to add and subtract these values, the 1 plus 4i minus 2 minus 5i, you'll get negative 1 minus I. Let's take a look at number 4. Well, it's the same idea as before. We have real parts, 4 and the minus the negative 3. We have imaginary parts. So when you subtract a negative 3, that double negative becomes positive. So really I have 4 plus 3, which I know to be 7. And then I have 3i, take away 2i, which is 1i. And we just usually write that as just plus an I. So there's our answer in our standard form. So I told you these weren't too bad. Hopefully you believe me. So I remember someone saying, well, what about the parentheses? Do they matter? Well, they kind of. Let's take a look. The reason that they have parentheses around here is just to indicate that there are two complex numbers that are written as standard form. Remember that the standard form for a complex number is a plus bi. So this 5 minus 3i, that's referred to as a complex number. This 1 plus 5i is a different complex number, and we can add them together. The process of adding them together, we know to add the real parts together and to add the imaginary parts together. So we have 5. So with the plus signs, I ignore the, I don't have to worry about the parentheses when I have a positive sign in front of the parentheses. I can think of that problem like that, and I'll get the correct answer. I won't have a problem at all. 5 plus 1, 6. Negative 3i plus 5i, or 5i minus 3i, might be a way to think about it. 6 plus 2i. Hopefully you can read my handwriting. So, that's my final answer. Let's take a look at some more. Let's take a look at 8. Now 8 is a little bit different than the addition. With the addition we ignored the parentheses, and in problem number 8 we can't quite ignore all the parentheses. We're fine with ignoring the parentheses when it's a positive sign out in front there. So it doesn't bother me at all to come in and just to ignore these parentheses. But I've got to be careful. I don't want to ignore these others, and I'll show you why. So I have 4 plus I. I'm subtracting a negative 1. And then I'm subtracting a 2, I. So you subtract everything inside the parentheses. So that's why we need that parentheses. If they weren't there, then we're just going to end up subtracting just the first number, because there's no indication to come in and subtract the second number. So yes, the parentheses matter, but they matter very drastically in a dramatic way when it's subtraction. Alright. So I have, let's simplify the double negative there. I've got 4 plus I, and I'm even going to put plus a 1i to help us out. The negative minus the negative number, hey, that's positive, and then minus 2i. So I have real parts of 4 and 1. I have imaginary parts of 1i minus 2i. So when I have 4 plus 1, I get 5. When I have 1i take away 2i, that's a negative 1i. So if someone asks me to subtract these two complex numbers, I say no problem. I get 5 minus I. What about number 11? All of a sudden, it's they can't really make the problem harder for us, so they make it longer. I suppose they can make the numbers large where the arithmetic was more of a challenge, but we do have a calculator, and we can use a calculator to add and subtract these values if we need to. So here we have three complex numbers here, each one of the form a plus bi, and we're just adding these complex numbers together, and the result should be another complex number. So let's focus our attention on the first two here. If I drop my parentheses there, I just have a negative 2 plus I minus 1 plus 2i. And let's put a 1 in front of that I. And we'll just leave the rest of it exactly as it's written. Alright. Let's add the real parts together, negative 2 and negative 1, and the imaginary parts, the 1i and 2i. So what do we get with the real parts? Negative 2 minus 1 is a negative 3. What do we get with the imaginary parts when you have 1i plus 2i? Well, that's 3i. And now when I subtract, I can come in and distribute that negative sign to both terms. When I subtract a negative 1, the double negative there becomes a positive, plus 1. And then when I subtract the positive I, it actually is written as minus I. And I'm going to put a 1 in front of there just to visually to help me. So I have a negative 3 and a positive 1. That's going to add up to negative 2. And I have 3 i's, and I take away 1 I, and that's 2i. Now that's 2i to the first power, so I can't replace, I can't do anything with that I. And I definitely don't want to add the real part and the imaginary part together. So that's my final answer. Let's take a look and see if there's any of these others that might help to see as examples. Well, sure, we've got, now we could jump in and do any of these ones for this later part. Let's do 13. I'm going to have to pause this real quick, and it won't seem like I'm gone at all when I come back. So I'm back, and I'll bet you that hardly is noticeable. Alright, so I'm glad that I picked this problem here, because we don't yet see, we need to simplify this before we jump in and try and start adding and subtracting. We have 1 plus, now the square root of negative 9, I can break that apart to the square root of negative 1 times the square root of 9. And that's my first complex number. I'm subtracting a complex number that only has an imaginary part. And I'm going to break apart this square root of negative 4 to square root of negative 1 times the square root of 4. Here, let's have 1 plus, by definition, the square root of negative 1 is I. And I can break 9 down to 3 times 3. I know that the square root of 9 is 3. That's a multiplication. I'm subtracting. Well, when I look here, the square root of negative 1 by definition is I. I can break 4 down to 2 times 2, so I have a pair of 2's. So this is just times 2i. So I have 1, and we normally write I times 3 as 3i, and we normally write I times 2 as 2i. So if I have 3 i's and I'm taking away 2 i's, I have an I left. So there's my final answer. So I had to come in and rewrite these negative radicals in terms of I to be able to get my final answer. So let's do some more of these, because these are a little more challenging. Let's jump over and do 16. I have 25 plus, now I'm going to break this square root of negative 121. I'm going to break it apart into the square root of negative 1 times the square root of positive 121. I'm subtracting this other complex number, negative 6, plus, I'm going to break apart this square root of negative 144 to be the square root of negative 1 times the square root of positive 144. So I have 25. By definition, the square root of negative 1 is I, and I can break 121 down to 11 times 11. So I know that the square root of 121 is 11. I have a negative 6 plus, by definition, the square root of negative 1 is I, and I can break 144 into 12 times 12. I have a pair of 12, so I have one of them that comes out from the radical. We normally write I times 11 as 11i. Alright, so what this is asking us to do is take this first complex number and subtract away from it the second complex number. So the parentheses in the first number really don't mean anything. So I can write the 25 plus 11i. But I want to be able to subtract both terms, not just the first term, or not just my favorite term. So when I subtract a negative 6, that double negative there is going to turn to positive. Well, now I'm going to subtract a positive 12i, because inside the parentheses I have to subtract each of these. What do I get? Well, the double negative becomes positive. And that's what some people are going to immediately jump to. They're just going to say, when I subtract this, both of these change sign, and the negative 6 becomes positive 6. But there's just a little bit more detail, a little bit more explanation. We've got a real part of 25 and a real part of 6. We have an imaginary part, the 11i, and imaginary part, negative 12 there. So let's add our real parts together. 25 plus 6 is 31, and let's combine our imaginary parts. 11i, take away 12i is minus 1i. So if I haven't made any silly mistakes, it's getting a little bit late and I've been here for quite a while today and I'm getting a little bit tired. But hope and anybody, as you get tired, if you don't have enough rest or if you're distracted, you're gonna make more silly mistakes. So I'm trying not to, but I'm hoping that I have these answers correct for you. Alright, so hey, let's do one more. Let's do 17. Alright. So let's keep the grouping symbols there for now. We're grouping together this first two numbers, that's because that's a complex number. We have a real part of 18, and this guy's going to turn into an imaginary part because we're going to break apart the square root of negative 36 to the square root of negative 1 times the square root of positive 36, and 36 breaks down to 6 times 6, so we have a pair of numbers. We can simplify that radical, that square root. We've got a negative 3. We're going to do the same thing with the square root of negative 125. We're going to break it down to the square root of negative 1 times the square root of 25, and 25, since 5 times 5 is 25, we know that we can simplify that square root. So we have 18. By definition, the square root of negative 1 is I, and the square root of 36, well, we know because we found a pair there, we know that this is times 6i, or times 6, I mean. This negative 3 plus, this, by definition, the square root of negative 1 is I, and that's being multiplied times the square root of 25, which, because 25 breaks down to 5 times 5, this is times 5. But you won't see it written like that very often. I have 18 plus 6i. That's how you're going to see that written. And then I have plus negative 3 plus 5i. So these are two complex numbers that we're going to add together. And we add the real parts and then the imaginary parts. So the real parts, 18 and negative 3. The imaginary parts, the 6i and 5i. So 18 plus a negative 3, or 18 minus 3, hey, that's 15. And 6 i's plus 5 more i's is 11i. So there is my final answer for number 17. So hey, I hope that helps. If you need some more, I can either create some, some practice problems, or I can do some of the rest of the ones on the homework there. So just ask me if you need any help. Talk to you later. Bye.